All right, hi there. Today I'm going to be looking at Chapter 10-3 for Algebra 1 of adding and subtracting radicals. So when you add or subtract radicals, they have to have the same number underneath the radical, and they also have to have the same root. Now in this case, they're both square roots, which means there's an implied 2. That little 2 there is called the index, and if there's nothing written there, it's implied 2, which means they're the same, and they both have an 11 underneath the radical. So what I can do is I can add the coefficients together. The coefficients would be the 6 and the 9. So if I just add those two together, 6 plus 9 is 15. And then I keep the square root of 11 as it is. That's the answer, okay? There's actually a kind of a cool way that I was taught about radicals. And that's, you can think about radicals as variables. You know, if I was to take 6x and I was to add 9x together, you get 15x, all right? There's nothing complicated about that. This is really the same kind of thing as the problem we just did, except that the x is the square root of 11, all right? So that's, you know, kind of a neat way to think about it. So keep that in mind as we're going through this, okay? All right, number 2, suppose I can also subtract. Suppose I had 6 square roots of 3 minus square root of 3. All right, so, you know, if you get stuck, think about variables. Go back over here. This is the same as 6x minus x. Also, if you'd like to think about what's the coefficient in front of that square root of 3, there's always an implied 1, which means I'm really subtracting the 6 and the 1, which gives me 5. And then I just keep the square root of 3. Notice how I don't go making it, adding what's underneath the radical or anything like that. Anything crazy like that. All right, number 3. 7 square roots of 2 minus 8 square roots of 2. You guys try this one. Make this a you try. You do it. 7 root 2. Sometimes you hear me say it that way. 7 root 2 minus 8 root 2. What do you get? All right, so welcome back. If you just simply subtract the coefficients, 7 minus 8 is -1 root 2, or good old negative root 2. One of those two answers would be great, since there's a 1 implied there already. Okay, number 4. Five root 5 plus 2 root 5. What do you get for that one? Do that one on your own also. Number 5. Root 3 minus square root of 12. All right, so here it starts getting a little different, a little harder here. I no longer have the same number underneath the radical. Unlike up here, you can just add those together because they both have square root of 5. This one, I got to break this up, okay? Otherwise, I can't add them together. But I can break up 12. Remember back, we already talked about breaking up radicals. 12 can be broken up into the square root of 4 times the square root of 3, because 4 times 3 is 12, okay? So I'm just going to keep this over here on the side for a moment, that 5 square roots of 3. Now the square root of 4 is 2, right? Good old regular 2. So I got this now. So now I broke that square root of 12 up into 2 square roots of 3. So now I've got 5 square roots of 3 minus 2 square roots of 3. And that I can actually combine. Simply subtract the 5 and the 2 and get 3. Keep the square root of 3 as it is. And that's the answer, okay? Why don't we try another one of those? Here's number 6. 4 square roots of 7 plus 2 square roots of 28. Okay, so add them together. Now remember, you can't add square roots of 7s and square roots of 28s, so you got to break one of them up. You're going to break the one that's bigger up. That's the way it works. So I got 4 root 7. Keep that 2 there. 28, especially if I look over here, I'd like it to be a square root of 7, which means 7 times what is 28? Well, that's a 4, right? So square root of 4 is regular 2, so I got a two 2's, and a square root of 7 over here, and 4 square root of 7 still left on the left. Now I can multiply 2 times 2 together, get 4 square roots of 7 plus 4 square roots of 7, and add those together. Remember, add the coefficients. 4 plus 4 is 8. Leaves me with 8 square roots of 7, and that's the answer. Number 7, when will you guys try this one? Five square roots of 32 minus 4 square roots of 18. All right, so hit pause and come back. You're going to have to tell you right now, you're going to have to break up both of those radicals. All right, so I'm going to do this one. Now, I'm going to start over here. This one's a little smaller. 18, perfect squares that go into 18 would be 9. I think 9 is the only perfect square that goes into there, which means I got 9 and 2. So if I look back at the right here and I'm thinking, I'd like to get this to be a square root of 2, because I can break 9 up into 3, right? That's 4 times 3 times the square root of 2, which gives me 12 root 2. So 2 times what is 32? That would be 16. And that's a nice one to pick because 16 is a perfect square. Square root of 16 is 4. So I got a regular 5, a regular 4, and a square root of 2, which gives me 20 square roots of 2 minus 12 square roots of 2. Well, this just got a whole lot easier now. Subtract the coefficients. 20 minus 12 is 8 square roots of 2. And that's the answer. All right, next, I'm going to show you how to multiply a little bit. Number 8. Suppose I got the square root of 10 times square root of 6 plus 3. Okay, so this is actually distributive property, all right? So I'm going to take that square root of 10, and I'm going to multiply it times the square root of 6 and 3. So square root of 10 times the square root of 6 plus 3 times the square root of 10. Okay, so that's how I'm starting. All right, so 10 times 6, that's 60. And let's see, what else can I do here? 60, I can break that up into 4 goes into that. And 15, which means it gives me 2 square roots of 15 plus 3 square roots of 10. Now, I can't combine those together, all right? Even though I really would like to, I can't. I just leave it like that, okay? And that's the reduced version of that problem. All right, next one, number 9. Foil or box technique. Square root of 6 minus 2 square roots of 3 times the square root of 6 plus the square root of 3. Okay, so this one. A little meat on this one. I'm going to make my box. I'm going to do it with box. If you like foil, that's fine too. Okay, so square root of 6, 2 square roots of 3, square root of 6, and regular square root of 3. Okay, so multiply square root of 6 times the square root of 6 is 6. Square root of 6 times the square root of 3 is the square root of 18. And I got this also, I got that 2 there, so that's 2 square roots of 18. Square root of 3 times the square root of 6 is 1 square root of 18. And square root of 3 times the square root of 3 is 3. And 3, it should have been negative, times negative 2 will give me negative 6. So that's what I get in that box there. This should be negative 2 squared root of 18. Okay, so now I add up what's in the boxes to get my answer. These two will cancel. 6 plus negative 6 is 0. Negative 2 square roots of 18 plus 1 square root of 18 is negative 1 square root of 18, or just negative square root of 18. And that is the answer. Number 10. Let's try another one of those. Those are tricky, or they're tricky at first. 3 plus the square root of 7 times 3 minus the square root of 7. So if I take, maybe I'll do this with FOIL. I did the last one with box. 3 times 3 is 9. Outside is 3 times negative 7 square root of 7, which is negative 3 square root of 7. Inside is square root of 7 times 3, which is 3 square roots of 7. L is the last numbers. Square root of 7 times the square root of 7 is 7. Okay, and then I can combine like terms here. These two actually cancel each other out. Those two right there, negative 3 square roots of 7 and positive 3 square roots of 7, that's 0. So I'm left with the 9 and the 7 together, which is 16. Okay, and that's the answer. I'm going to leave one more problem here for you. This will be a U try. I want you to FOIL out 2 plus the square root of 3 times 4 minus the square root of 3. Okay? You do that one on your own, bring it into class, show me the answer. You can do it with FOIL or box, however you like it. 2 root 3, 4, negative square root of 3. Okay, anyway, I'm going to leave it like that. And you can show me your answer when you get into class. All right, have a great night. I'm going to close it out with some more music.